Hey, hi guys. Today we are going to solve this problem maximum number of alloys. You are the owner of a company that creates alloy using the various type of metals. There are n different types of metals available and you have access to K machines that can be used to create alloys. Each machine requires a specific amount of each metal type to create an alloy. For the ith machine to create an alloy, it needs composition Ij units of metal of type J. Initially, you have a stock I units of metal type I and purchasing unit 1 unit of metal I cost of I coins. Given integers n, k, and budget, one base indexed 2D array composition and one base index array stocks and cost. Your goal is to maximize the number of alloys that company can create while staying within the budgets of budget coins. All alloy must be created with same machines. Return the maximum number of alloys that company can create. So here we have to remember this point where we have all alloys must be created with same machines. So we have to maximize the number of alloys that we can create with given budget. Okay, so this is so if we go to the constraint here, we can have budget of 10 to the power 8, N and K are 100, and stock cost length is N, and stock and cost can be these values. So this is one of the best example of binary search. So there are a lot of problems that can be done through the binary search in an optimum way. So during my college days, I used to implement solve these kind of problems using the binary search. So we are going because we know कि any one machine will be used to build all the alloys, and we have given budget, and budget can shoot up to this value. So obviously if we know the some value, uh, budget value, we have to find the number of units where we can uh, say this number of units we can build uh, through the ith machines and using the compositions. So let's see how we can do this one. So first, what we need, suppose we have given the ith machines, then how can we calculate what is the maximum number of units, alloy units we can build? So let's try to do here. Int max alloys, we are giving some name, and we are taking some budget. So let me go to here. Here we will take n because n is the here we have given n and k are given, where n is the different type of materials. So if we choose ith machines, so there are and different types of metal. So and we have taken, and budgets we are going to take in long to avoid those scenarios where value can exceed the 10 to the power integer range. So here we are assuming we have composition from the ith machine. So here we can mention as a current composition, and here we can consider the stock of metals given, and same cost we have to consider. So suppose if we have to find through the ith machine, so this parameters will be sufficient. What values we have to take? We have to take unit thing we have to consider. So we will take 0 unit, a 0 number of units alloy can be considered initially, and here we will take these values. Basically, sorry, here we will take low, and high and mid. Initially, we will slice the low with the 0, high with the integer max. Okay, and now we will iterate where low is less than equal to high, and here we are going to put a business logic, and finally we will be returning answer. So how we will have to do this thing? So first we will take mid. So to avoid the overflow, we will do in this way: low plus high minus low divided by 2. Okay. Now these number of units alloy we can build. Okay. And we have already given the stocks of I type of metals. So here, so there are total n types of different metals. So what we are going to do, we will iterate through 0 to nth, and here we are going to consider long current total cost, how much it will cost for building mid units of alloy. Now here what we are going to do, we will consider so stock needed. So stock needed for ith metal, how we are going to calculate math dot max 0, and it can be possible stock is already higher than this value, even if we are considering x units of ith metal. If it is still greater than stock, obviously we will require 0 extra. So here we can put extra stock needed, and here, okay, here what we will do, mid units, so we will multiply with 1l to convert into a long, and here these much units we required. So we will get the cost also per unit. So it will be total cost to this one, uh, sorry, stock, extra stocks we needed. So here what we will have to do, composition, current compositions. So ith element composition we need for one unit this much, and we will multiply by mid one, and we will minus the whatever stock is already given. We have provided stock of I. So this much extra we need. So total cost will be, current total cost will be this much extra we required, and we will multiply by here cost of ith per unit. Okay, and after that we will get the final cost. So we will check if this current total cost is less than equal to budget, then obviously this can provide the answer. So answer we will take math dot max answer comma mid, and we will update low to mid plus 1. And if it is not, then we will have to update high as a mid minus 1. Okay, and it will go till this condition. So now we have done it for one machine, so we have to do for all machines. So we will start with the 0 here, and we will go follow here integer current composition, and we will iterate through all compositions. Okay, and we will figure out the answer mat dot max answer comma max alloys which we can build, and we will pass, and here we have to pass budget also, so we will pass budget also, and after that current composition and whatever stock we have provided and the pricing. Once we are done with this one, we will return the answer. Let's try to run on sample examples. Okay, there is some issue. Current composition. Okay, we have passed budget, current composition, stocks, and these things. After that, what we have done, current composition line number 28, 12th. Sorry, here it should be stock. Now try to run it. Composition. Okay, it is working fine for sample cases. Let's try to submit it. Yeah, it's working fine.